Hi. So today's topic is unit conversion. You may also hear this referred to as dimensional analysis. They're the same thing. Um, so as we go throughout today's lesson, you will be learning how to convert from one unit to another. When you're converting units, a key point to keep in mind is you should always start with a given value in the problem. You will also be multiplying by fractions. We call these fractions conversion factors. When we set up unit conversions, pay attention to the units. Particularly, pay attention to make sure that your units are canceling out, meaning that you should see all of the units canceling and only leaving you with the desired unit. So today you're going to be taking notes. In your guided notes, you'll notice there are gray boxes. Make sure you're filling these out. I would prefer if you used a pencil in case you have to fix anything as we go throughout the lesson. Okay, so we're going to start with a little bit of math review. And so if we look at the number 1, any number times 1 is the same as the number you started with. This means that 14 times 1 is 14. 5.49 times 1 is 5.49. 8 times 1 is 8. 23 times 1, hey, that equals 23. 2.7 times 1 is 2.7. All right? Any number divided by itself is also equal to 1. So that means that 4 divided by 4 is 1. 5.43 divided by 5.43 is 1. 14 divided by 14 is 1. 2000 divided by 2000 is 1. 10 divided by 10 is 1. Further, we know that any number is equal to itself. 4 is equal to 4. 5.43 is equal to 5.43. 14 is equal to 14. 2000 is equal to 2000. 10 is equal to 10. So now that we've reviewed some basic math, we're ready to learn about unit conversions and see how this connects in. So in a unit conversion, we have an equality, such as 1 foot is equal to 12 inches. That means that 12 inches divided by 1 foot equals 1. Why, do you ask? Is 1 foot, or why are we going to get 1 here? Well, 1 foot equals 12 inches. So if the top and the bottom of a fraction are equal to each other, then it equals 1. So this means that 12 inches divided by 1 foot is 1, and 1 foot divided by 12 inches is also 1. So if I have 84 inches times 1, I get 84 inches. Okay, our value hasn't changed. Well, because 1 foot divided by 12 inches equals 1, I can multiply 84 inches by this fraction and not change my value. Notice there are two ways to arrange our fraction here. I can arrange it as 12 inches divided by 1 foot, or 1 foot divided by 12 inches. So how do we know which fraction to pick? Well, we look at our units. Remember, anything divided by itself is 1. This means that 12 inches divided, sorry, let me go back. Inches divided by inches is 1. Okay? So 84 inches has the inch unit in it. We need to make sure that the inch unit is on the bottom of our fraction. And so we're going to pick the fraction that has inches on the bottom so that the units will cancel out. Okay, so always make sure your units cancel. This means that the unit in the numerator or the top of the fraction will appear in the bottom of the fraction and then the conversion factor that follows. And so what this means is we're going to look at our numerator and our denominator and make sure that they're canceling. Now, sometimes people are like, but Mr. Everett, 84 inches, that's not a fraction. It is. It's just a fraction written over the denominator of 1. We don't write the 1, but it's there. And so that means that we can look and we can find that we've got inches in the numerator and inches in the denominator. They will cancel out. Okay, so remember, this fraction is the same as multiplying by 1. It's not going to change our value. It's just changing the units. So we can see that 84 inches is equal to 7 feet. If I were to measure out 84 inches and I were to measure out 7 feet, they're the exact same distance. The only difference between the two is the unit we're referring to that distance by. And so the unit conversion will allow us to have something measured out in 84 inches and convert it to a different unit, in this case, 7 feet. Right. So we're going to be giving you a few practice problems, and I want you guys to try these on your own. So when we give you the problems, I'm going to have you pause the video. You're going to try to solve it on your own, and then you're going to resume the video. You're going to check your work. If you made a mistake, I want you to use a pencil so that you can fix it if you need to. While you solve these problems, you do need to be writing it out and showing your work, including your units. And I also expect you to use a calculator. So if you don't have a calculator, go borrow one. There's some in the cupboard. Go grab one. Okay, so we're going to get started with our first one. So I want you to convert from 54 inches to feet. Again, if you need to borrow a calculator, please do. And then pause the video, and we'll be back in a second, and you can see how you did. All right. So I hope you were able to solve that and it went okay. Again, you're going to take 54 inches, and in this case, you're going to times it by 1 foot over 12 inches. And that way, our inches canceled and we got to feet. If you made a mistake, that's why you did it in pencil. Erase it, fix your notes. Okay. So we're going to do the next one. And so in this one, I'm giving you two conversion factors. You have 1 foot is equal to 12 inches and 1 yard is equal to 3 feet. So see if you can convert now from 54 inches to yards. Again, pause the video and try to solve this problem on your own. All right, so how did you do? If you made a mistake, again, fix your work. Please pay attention to details here. I do want you making sure you're plugging in both your numbers and your units. So if I were to plug this into my calculator, I would take 54 and I would divide it by 12 and I would divide it by 3 and I would get 1.5. Your final unit is yards. Some students have a preference that they like to multiply everything across the top, and then they multiply everything across the bottom, and then they take the top divided by the bottom. If you prefer this method, what you would have done is you would have taken 54 times 1, and you would have gotten 54. And you would have taken 12 times 3, and you would have gotten 36. You would then take 54 divided by 36 to get 1.5. And so that method works just as well. Okay, so try this conversion problem. Remember, set it up as we've been practicing. Show your units. Make sure your units are canceling out. Pause the video and see if you can solve it. Okay, so how did you do? Remember, the first step with any conversion factor problem, like when we're doing unit conversion, is it's going to be the units. So the first step will be setting up the units correctly and making sure they're canceling out correctly. So we've got our units here. We can see that they are canceling. And so we're going to move on now and plug in our numbers. So now that we have our unit set up correctly, we plugged in our numbers and we can see that we have our given on the left and our conversion factors come after that. Always make sure you're starting with a given and then you're adding in your conversion factors. Remember, conversion factors are the equalities, meaning they are the fractions that came from the equalities that we got from our start of our problem. And you're going to be getting these equalities from your conversion factor paper and from the metric system. Remember, you memorize the equalities from the metric system. And so both of those can be used as conversion factors. An example of the metric system would be the fact that there are 100 centimeters in a meter, which means that the conversion factor to convert from, say, meters to centimeters, well, you would make sure that your meters are going to cancel. So you could take 100 centimeters divided by 1 meter, and that could be your conversion factor to get from meters to centimeters. Okay, so I want you to try one more. Remember, you got your conversion factor paper to help you with the equalities and to find your fractions for your conversion factors. Pause the video and see if you can solve it. All right, so double check your work, fix your notes if you need to. How are you feeling about conversion factors? Are you feeling good about it? Are you mastering this skill? Can you kind of give a little thumbs up, thumbs down, thumbs sideways to your neighbors? Where are you guys at? If you're feeling like you're struggling, take a couple of seconds and try to identify what exactly isn't making sense. Okay, if you can identify where you're getting stuck, it will help you be able to get to where you can understand it. So take a second, and now that you've had a second to think about where you're struggling, check in with your neighbors. Are they understanding how to convert from one unit to another? Are they understanding how to set up unit conversion problems? If not, can you maybe pause the video and talk with each other and explain to your neighbor how unit conversion works? Okay, I hope you guys were able to talk about unit conversion and that you were able to help your neighbors. So, something to keep in mind with unit conversion is it's all about what's going on with the units. Okay, so there's a pattern. Can you see the pattern? Like this top bottom pattern that we have going on here in this unit conversion? Okay, here's a little song that I like to sing that helps me to check my units and make sure that they're canceling out correctly. And here's how the song goes: top, bottom, top, bottom, top, bottom, top. Look at your units, you'll know when to stop. So as you sing that song, you can see gallons, gallons, quarts, quarts, pints, pints, cups. Looking at our units, we see that gallons, quarts, pints are canceling, and we're left with cups. Okay, so this next problem is a little bit more challenging, and we're going to look at two different ways of solving this one. Um, we're going to solve it together. And so I have here what we call a picket fence. It's a way that we can quickly set up unit conversion problems, and we'll see them more in the future. So first off, we're going to plug in our given value. So we plug in our given value with its number and its unit. Okay, as I look at this, I'm going to try to go from yards to kilometers. I can look at my conversion factor, and I'm not seeing any conversion that goes from yards to kilometers. So I need to pick one that's going to get me closer to kilometers. And so what does this mean? Well, I'm going to look at my conversion paper and I'm going to say, I'm going to try to go from yards to miles. And so I pick that conversion factor paper. I'm going to copy yards from my given, and I'm going to paste it on the bottom of the next fraction. And then I put miles on the top. Okay, I can then see that I can go from miles to kilometers. So I'm going to copy again miles, put it on the bottom, put kilometers on the top. Okay, we do a little top, bottom, make sure our units are canceling. And sure enough, they are. We're left with kilometers. Right? So our units are canceling. Everything's set up correctly. Now we just need to plug in the numbers. So we go back to our conversion factor paper and we look and we say, okay, well, I can see that 1 mile is equal to 1,760 yards. So plug those two numbers in. I can see that 1 kilometer is equal to 0.621 miles. Plug those numbers in. Of course, matching them up with the correct unit. And plugging it all into the calculator, we get 0.672 kilometers. So how to put this in the calculator? I'm going to talk about a few different options here, and then I'll talk about the one that I prefer. So really, you just need to be plugging it in a way that you understand. And so pick the method that works best for you. Something that you could do is you could take 735, you could times it by 1, and you could times it by 1, and then you could divide that by the next part of the denominator part in parentheses. So 1,760 times 0.621, and that would give you the answer. Now, you might have noticed when doing this that 735 times 1 is going to give you 735. Feel free to skip the times by ones and the divide by ones because multiplying or dividing by 1 doesn't change your value. Also, please notice how and why did I use parentheses here? Okay, it's kind of important that you understand what's going on with the parentheses. Okay, so breaking that same method up into two different parts. Some students prefer to multiply everything across the top. We call that the numerator. And then they prefer to multiply everything across the bottom. We call that the denominator. And then they like to take the top, the numerator part, divided by the bottom. And so if we do that, we can multiply across the top and we get 735. And we can multiply across the bottom and I get 1092.96. Please note, I did not round yet. You don't want to round until you're done, until you're getting the final answer. That's why I wrote the whole thing out. So then we can take the top, we can divide it by the bottom, we'll get our final answer. The method that I prefer is a little bit more simplified, and the rule that I use is top multiply, bottom divide, and we skip ones. So that means I would take 735 because the 1,760 is on the bottom. I divide by 1,760 and then I divide by 0.721. And that's it. So top multiply, bottom divide. If a number is in the numerator part, we're going to multiply by that number. If it's in the denominator part, we're going to divide by that number. And that's it. Okay, so we've now done some unit conversion. We were able to go from yards to kilometers, and this had two steps. We went from yards to miles and miles to kilometers. Notice we did write them all in together, and that is correct to not do them individually, do it all together. Okay, here's another setup, another way that we could have solved the same problem. And yes, there is more than one way to solve a unit conversion problem. In this case, we can check and see if this is right. And so we're going to sing our little song. We go top, bottom, top, bottom, top, bottom, top, bottom, top. Look at your units, you'll know when to stop. Sure enough, all of the units are canceling and we're left with kilometers. Okay, then we go to our conversion factor and we check our numbers and we can see that 1 yard is 3 feet, 1 foot is 12 inches, 39.4 inches is 1 meter, and 1,000 meters is 1 kilometer. So yeah, this is set up correctly, and it solves the problem correctly. It's It's okay to have more than one way of solving a unit conversion problem. And so we can see that there are two totally correct, valid ways of setting up this unit conversion. And the key things to keep in mind are your units canceling? And did you plug in the numbers in the right spot in your conversion factors? Meaning the numbers should match both the unit and the equalities on the conversion factor paper. So we're going to shift gears just for a second. This is mostly just a little bit of a review. But water, we know water is kind of a big deal because it's everywhere. Chemists, out of all the chemicals that anybody ever interacts with in their life, water is the number one chemical that we interact with. And so, not surprising, it kind of connects a lot to how we think about and do a lot of chemistry. And because of this, it has affected the way we use units. And so, our units and water have a special relationship. And please note, this is only for water. Now, we did talk about this before, but it's a bit of a review. With water, and only with water, can you interchange the gram and the milliliter. Why? Because 1 gram of water and 1 milliliter of water are equal to each other. Therefore, grams and milliliters can be interchanged because the density of water is 1 gram per milliliter. So please note that this applies to water and only with water. And you might see units changed from grams to milliliters, milliliters to grams with water. All right. So to kind of wrap up this unit conversion lesson, I did want to talk about for a little bit why sometimes you can set up your problem correctly and someone else sets up the problem correctly and you get slightly different answers. Okay, this is okay. These two numbers, 8.04 and 8.03, are really close to each other. But why then are we not getting the exact same number? We set them both up correctly. The units are canceling. All of these numbers are correct. Well, it's because of what we call exact and inexact numbers. More specifically, it's because of rounding of our actual conversion factors. And so to better understand this, we need to understand what an exact number is. A good example of this is a dozen. If I have 1 dozen eggs, you know that I have exactly 12 eggs. This is not 11.9 rounded up or 12.3 rounded down. It is exactly 12 eggs. 1 dozen is 12 by definition. So exact numbers can be things like a dozen, which is exactly 12, or other types of definitions. For example, the metric system. Okay? A centimeter is defined as 100th of a meter, which means that there are exactly 100 centimeters in a meter. These numbers are exact. Further, there are other definitions. For example, the inch has actually been defined by the metric system. An inch is defined as being exactly 2.54 centimeters. In this case, the numbers 1 and 2.54 are both exact numbers. So you might notice on the slides it's talking a little bit about significant figures here and how there's some sig fig stuff going on. So significant figures and exact numbers. When you have an exact number, because they are defined as exactly that number, they also don't have a limit to the number of sig figs they have. They have unlimited significant figures. Therefore, when we use them in our problems, they do not limit or decrease the number of significant figures we have. Inexact numbers, however, can affect your sig figs. So in your problem, you can see that you have 4.93 milliliters, and this 4.93 has been rounded to the hundredths place. And so it only has 3 sig figs, and so it affects your sig figs. And we can also see that we have 0.946. This also has been rounded, has 3 sig figs, and so also limits our numbers. And because of the rounding, we actually ended up getting slightly different numbers here. And so that is something to consider and something to be aware of. when you're doing unit conversion. I hope you're understanding unit conversion. I hope you're feeling confident and this is making sense. If not, please take advantage of the fact that this is a video. You can watch it again. You can pause it. You can take some time to reflect, go over your notes, identify where you're struggling, and then go listen to that part again. So please take the time to work through this concept and master it. It really is one of the most important concepts we cover in this unit. So please, please, please master it. Otherwise, good luck in your studies. You do have a practice quiz to work on, so please go work on that. And I will give you the rest of the time to get your work done. So thanks for all your hard work, and we'll talk to you later.